Hi, I'm Arpit, a second year PhD student in physics, and my PhD revolves around tungsten telluride, which is a two-dimensional topological insulator. And recently, it has shown robust topological states up to temperatures of 100 Kelvin. Now, to understand what topological insulators are, let's start by considering this laptop, which I'm using to record this video. So it has a 16 GB RAM, and it can do a lot of things. But what if I need to solve a problem of molecular dynamics where I'm dealing with 10 raised to the power 23 particles at once? I think I need a supercomputer. So what I'll do sitting here in NTU, I'll upload my job on National Supercomputer Cluster, and I will be able to see everything on my screen, but the actual job is performed somewhere else. So the question arises, what can be done so that these kind of jobs can be done on my computer, on this laptop? Unfortunately, the only answer is that we have to get beyond silicon because silicon electronics has now saturated. And one probable answer to this question is these materials called the 2D topological insulators. So, firstly, being two-dimensional, these materials will definitely bring down the device size. Secondly, the definition itself will give you a reason. So suppose this my hand is a 2D topological insulator. So this central portion, which is called the bulk, is an insulator. However, these edges are perfectly conducting edge channels. And an observation of these perfectly conducting edge channels in tungsten telluride up to high temperatures of 100 Kelvin is itself a big step towards future. Now, why is it significant? Because this is how electron moves in silicon. And at the edge of topological insulator, this is how electron moves. Now, these kind of materials also provide us new ways to control the device. Suppose I have this edge resistance as a function of magnetic field orientation. So this tells me that if I change the direction of a magnetic field, I'll reach an orientation where my device is now switched on because the resistance is very, very low. And I can similarly reach a state of switch off because my resistance is very, very high just by tuning the direction of magnetic field. And this on state is remarkable because if you note that this is robust to temperature fluctuations. So this will definitely help us reduce the energy related heat loss. With this, I would like to thank you and please vote for me.